In this section, we are still working with inference, but in this case we're working with two means that are dependent rather than independent as we have in previous sections. And these are called matched pairs design. So when we're talking about a matched pair, what ends up happening is we have something like a subject 1, and then we might have something with subject 1, a before and an after listing. And then we'd go on to subject 2, and then we'd do the same thing, and we'd have some sort of a before and after. So let's say the length of time it took for them to complete a puzzle before some training and then after some training. So before training might have been 121 minutes, and then after training they were much faster, 110 minutes or something like that. So the important part here is these are matched. This before and this after are matched. They're related. So they're no longer independent of each other but dependent. And then what we do is we go ahead and we continue on in this same kind of pattern, and we look at it before and the after. And again, these are all matched. Now, instead of looking at the average of the before and the average of the after, we look at the difference. So we take the difference of each of these. So we take 121 minus 110, and in this case that would be 11. 110 minus 100 would be 10. And then we would keep doing this for all of our subjects, let's say up to 10 subjects or something. Then what we do is on this difference, this is our new data set. So this makes up our new data set. And then based on this new data set, we can grab our calculators, and on the calculators we can do a test or a confidence interval, either one. Depends on what the situation is. Under stat tests, and we would look under the t-test, because we don't have two samples anymore, because we took our two pieces of information that were matched, we took their difference, and it just creates this one data point for each subject. So I would look under the t-test, or if I'm looking for a confidence interval, I'd look under t-interval. So I would run the t-test or the t-interval. Now the important thing to remember is the direction that we take this. So this difference was before minus after, so I need to make sure that when I'm taking the before minus after, I do that for every single subject. The best thing to do with these, I think, is to go ahead and get started with a problem and a data set. You'll definitely want your calculators. We're going to be looking at critical values as well as confidence intervals and the p-value approach to hypothesis testing. So some of this will kind of bring up the traditional approach, and some of it will bring up a p-value approach. So for our first example, let's go ahead and look at a data set. So for this data set, we're going to be asked to find quite a few different things. We're not going to be asked to find a conclusion about anything. We're just going to want to learn how to find the different components for a test using a matched pairs design. So for this particular data set, this would be subject 1, the x and the y value. So these are related. So when I record 4, I also have to record 9 right across from it. So let's go ahead and write down the rest of this data set. Okay, now to enter this data, what we want to do is we want to find the differences. So the difference is usually made up of x minus y, or the first value minus the second value. So these differences would be 4 minus 9 is negative 5, 17 minus 3 is 4, 13 minus 12 is 1. Here we have negative 3 is 0, 11 minus 8 is 3, 15 minus 12 is 3. Now if we had a really big data set, we probably wouldn't want to have to do this by hand, but we can definitely do this. Now let's look at the first question here, is D bar. So this is basically finding the average of the differences. So I would take negative 5 plus 4 plus 1 minus 3 minus 3. Of course, plus 0 doesn't mean anything, but I want to make sure I include that so I see that I need to include all the values. And I have 1, 2, 3, 4, 5, 6, 7, 8 data points. So to find D bar, looks like I have 0 over 8, which is 0. So the average of the differences in this case is 0. Now we can have our calculators help us out a lot with this. So to work with this in terms of your calculator, we go to Stat, we'd go to Edit, because we want to edit our list. And remember, if you have data already, just go ahead and go to the top column and hit Clear and Enter. And then what we want to do when we enter this is we want to make sure we enter them as pairs. So our first pair would be 4 and 9. Now you don't have to jump back and forth like this to enter the 4 and 9 at the same time, but we need to remember when we get done that there's a 4 has to be across from the 9. So we could just enter the entire row, the 4, 17, 13, 9, and then we have another 9 and 2 11s, and a 15. Okay, now when I enter my data for the Y values now, I need to make sure they're lining up. So across from the 4 was the 9, across from the 17 is the 13, meaning I can't randomize these. I want to make sure that they're kept in this particular order. And I have another 12, 11, 8, and 12. Now what I want to do is I want to have the calculator find the differences. So what we can do, if you notice my black box right here is in the first cell. If I arrow up, I'll be in the header cell. And what I want to do is I want to take the first row minus the second row. So in my case, this is L1 and this is L2. So let's go ahead and look at writing that formula. So again, it has to be up here in the column header. I'm going to go to second L1, and then I want to subtract L2. And what that does is it automatically fills in all these values that I had already found. And then to find my summary values, I can go to Stat, Calc, one variable statistics, and then in my list I want to work with the third column. I don't have a frequency list, and we can just go ahead and calculate. And then from here, I can see all my summary values. Now for this particular problem, we can see that the D bar matches with what I think it should be. The standard deviation of the differences is going to be the S because it's based on a sample and not a population. So this would be 3.3381. Now we have to remember here, just follow the directions for rounding that are given in MyMathLab. And let's say we're also asked to find our test statistic T. Well, if you look, we don't have a test statistic here. We can get one very easy though by going to Stat, Tests. And remember, I want to go to the t-test, and I only have one sample now because I took the two columns, took their difference, and combined them into that third column. Now my options here are data or stats. Stats would mean I would fill in the values for mu, x bar, s, etc. Or I can just go back to data, and what it will do is it'll pull the data off of, in this particular case, L3. Now the hypothesized difference, we haven't really talked about that because we haven't seen an example of it yet, is always 0. The alternative hypothesis will be the less than, greater than, not equal to case. Okay, so our data is in L3, so that works good. Frequency is 1, meaning each value occurs once, each pair occurs once. And here I'll just look at the not equal to case to find my test statistic. And to find the test statistic, it doesn't matter which one I look at here. What the difference is the less than, greater than, and not equal to will matter when I look at the p-value. So we'll go ahead and calculate that test statistic, and we can see here that the test statistic is 0. Now the reason the test statistic is 0 is that the hypothesized mean from my null hypothesis and my x bar are the same. Now specifically, they didn't give us any information really about what the alternative hypothesis, but the null hypothesis is actually usually going to be equal to 0. Okay, so that t equals 0 comes from right here. Okay, next thing, let's go ahead and look at the critical value. if we were testing our hypothesis. Now for the critical value, let's go ahead and look at alpha equal 0.05. And we'd also need to know something about HO and HA as well. So HO, I'm talking about the mean of the differences, not the difference of the means, not mu before and mu after difference, but the mean of the difference column. And that's usually equal to 0 for the null hypothesis. And then if we're trying to see the alternative, if mu equals d, mu d equals 0, the alternative is usually not equal to 0 unless you see the words like less than or greater than involved. So for our critical value, what we have here is a two-tailed test then. We had, in our sample, we had 8, so we know that this is T curve with 7 degrees of freedom. And we have 0.05 to distribute to two tails, so I split that in half to 0.025. So now it's been a while since we've looked at some of these, but to find our critical value, we would come over here to second DISTR for distribution, and we're looking at the TCDF. Now for the TCDF, the lower we can see is this shaded area. Okay, so for the lower we can see that this is going off toward negative infinity or some very large negative number. And a lot of times we use negative 100,000. And the upper is what we don't know. Okay, so I guess we can't use TCDF here because we don't know the upper. What we know is the area. So instead of using TCDF, we would need to use the inverse T. Now some of you have this under programs on your calculators if you had to program it in. So let's try inverse T instead. Exit out of that. So the area is 0.025. So this one is asking for area. Degrees of freedom are equal to 7. And we can see that my value here on my curve is negative 2.365. We'll say if we round this. So negative 2.365, positive 2.365. So those are my critical values. Now I could make a decision here because I know that my test statistic has been calculated as 0, but the first question in your homework set doesn't ask you to do that. They just ask you to find the critical value. But if I did have to find a decision here, if you notice my test statistic, which is right up here at 0, if you notice 0 falls in this fail to reject region, the only thing that I would worry about is anything that falls in these shaded regions would be my rejection region. But for now we're just going to just find a few of these values instead of actually drawing out the full formal test where they're just asked to find a few of these values. Okay, so for the next problem, let's look to see how we would do this for a confidence interval. And again, we're not asked to find any conclusions yet. We're just looking at how we could use our calculators to find a lot of these summary values. So for our next one, let's go ahead and look at another data set. Now this one, they tell us x sub I and y sub I. Well, the x sub I and y sub I basically mean the ith subject, so x1, y1, x2, y2, etc. So our data here is a fairly large data set as well, has 8 values. The first match pair is 17, 14, 10, 13, 9, 13, 11, 14, 7, 3. Actually, let's make this 7, 5, so it can be consistent here. So 7, 5, 9, 12, 1, 6, 15, 13. Now, I could look at the differences here. You know, I could underline this and look at the differences, but I'm going to have my calculator do that work for us. So in my calculator, I'm going to take xi minus yi to create my differences. So let's go ahead and grab the calculator. Remember, this is under Stat, Edit, and I can clear my lists. I can just go up to the top of each column where the heading is and hit Clear. You can also do this all at once if you go to Clear Lists and then just enter each of the L1, L2, and L3. Remember, these need to be entered as pairs, 17, 14, or you can enter the whole column, and then after you're done entering the column, just make sure that they're aligned properly. So I have 17, 10, 9, 11, 7, 9, 1, and 15. Okay, so that's my first column. Let's go ahead and check out my second column. 14, 13, 13. 14, 5, 12. 6 and 13. Again, these have to be entered in order for the match pairs design to work. Now here in column L3, I want to arrow up till this is highlighted, and I want to write out my formula. Now my formula was xi minus yi, so that's L1 minus L2. So I'll go second L1 minus second L2, which is above the 2 key, and that'll automatically take all these differences for me. And then I can go into stat, and I could look at all the summary values if I want, but for this one I want to do a 95% confidence interval. So I'm going to go over here to tests, and I'm going to look for a t interval. Now this is giving me the option. I can input my raw data from the columns in my list, or I can type them in. Okay, I want to go ahead and just take my raw data from the columns. This is going to be an L3, and let's say for this example I want to find a 95% confidence interval, so I'll put in 0.95. Okay, and that gives me all my summary values. Let me do that one more time. So stat, tests, we're going to be looking at a t interval, and again I want to use my data from the columns, L3, 95% confidence interval. Let me go ahead and do a screen snip of that, and then we'll put in our results as well. So we're looking at a 95% confidence interval here. And then we'll kind of talk about what this confidence interval means in terms of the difference. Okay, so this is our confidence interval right here. So again, this is a 95% confidence interval. And this was calculated based on L3. L3 was my third column of data, which would have been the same as taking the differences 17 minus 14, 10 minus 13, 9 minus 13, 11 minus 14, etc. Okay, but again, we can have our calculator do that for us, and this is L3 then. This column or this row is L3. Now if we look at this confidence interval, again, make sure you round as it says to round in MyMathLab. Make sure that you take into account the fact that 0 is in this interval. Okay, so let's just make a few notes. First of all, 0 is in the interval, and the interval that we're looking at is, let's say, negative 4.02, and the mean of the differences is in here to 1.27. Now because 0 is in here, that means the differences could be positive, the differences could be 0, or the differences could be negative. So what this is telling me, because 0 is in the interval, I cannot say anything about whether xi or yi is always going to be greater than 0 or less than 0, because the entire interval has both negative, positive, and 0 numbers. So there's really no conclusion here because 0 is in the interval. Now usually what we'd be testing here for a confidence interval, the mean of the differences equals 0 versus the mean of the differences does not equal 0. So this is the confidence interval case. So really from here, I can't really draw a conclusion about which one is greater or which one is not greater. So I would have to fail to reject HO. because 0 is in the interval. Now sometimes it doesn't ask me to go this far, it asks me just to find the interval, but if they do want some more information, it's good to write out your hypotheses and then draw some sort of a quick conclusion based on this interval. And again, 0 is in the interval is the key. Now most of the homework problems, you're checking to see whether the difference is equal to 0 or not equal to 0. But again, if you see that word greater than or less than, make sure you take that into account for your alternative hypothesis. So for our next example, our next data set, we have two different types of corn. And then we're looking at the yield for each type. So we have type 1 and type 2, different types of corn seed. Now what makes this a matched pairs is each of these was planted on the same plot of land. So the yield that we're looking at is 2,096 bushels and 2,047 bushels. So again, this is the same type of plot of land, so it has about the same type of water, same type of soil, etc. So we're looking at different yields on the same plot of land. So it's important that we have these matched because the plots are the same. Now after we get all of our data down, we can start looking at running a formal hypothesis test on this to see if there is a true difference or if the seeds yield about the same. Now if there was a big cost difference in the seeds, this would be good to know, and it would also be good to know if there was something else going on in terms of the types of seed. Maybe one of them was from a different company or something like that, so we might want to know the true difference. Okay, so what I want to do is I want to go ahead and test the hypothesis that the mean of the differences, and again we'll use our calculators to help us find that, equals 0. So that means the seeds are the same yield on average versus the average yield, the average of the differences does not equal 0. That means one is better than the other. Okay, let's go ahead, that's step 1. Step 2, let's go ahead and do this at the 5% level of significance. Step 3, we're going to want to have our test statistic. And then step 4, we'll go ahead and want to find our p-value. But let's go ahead and enter our data first. So let's go ahead and practice entering that data. So that's under Stat, Edit. And if you want to see another way to clear the lists, we can go under Clear Lists. And then we could go to second L1, second L2, and then second L3, and then it'll clear all of the data that was in there before. So Stat, Edit, this should be cleared now. And then I can enter L1, L2, and L3. So I'm going to pause the video for a minute while I enter all this data, and you try it too on your calculators. Okay, so I have all of my data entered, and what I want to do then is to write my formula for L3, and for this I want to take type 1 corn minus type 2 corn. So that's going to be second L1 minus second L2. And what that will do is it'll take all the differences for me, and then I will have this column of data, this L3, to work with. Okay, so let's go ahead and write that out real quick. So my differences were type 1 minus type 2 corn. So when I entered my data, this was L1, this is L2. So L3 were my differences, and that was equal to my type 1 minus type 2, which was L1 minus L2. Kind of just gives me a frame of reference to write these down. So now to find my test statistic, what I'm going to do is you'll go into Stat, Tests, T-Test. Now in our T-Test, we want to make sure that we're using our data set that is an L3. So this fact that L3 is listed is very important. Now we're at the not equal to case, so I have to make sure that's highlighted, and then we go ahead and click Calculate. Now before I click Calculate, I'm going to do a quick screenshot of this so we have a record of the data that we put in to come up with these values. Okay, and then we'll go back and hit Calculate. And these are our summary values. So I have my test statistic, and I have a p-value, and it also lists my sample size and my standard deviation as well. Now after we get done with this problem, I'll list the actual formula for the test statistic, But again, some of these formulas are getting pretty complicated, so a lot of times it's just better to use our technology to help us out with that. So we can see here that this is our test statistic. And so we get t equals 1.721. And just make sure you read your directions for rounding. Now my fourth step is to calculate the p-value. Our p-value is given to us in this case. Our p-value, because this is a two-tailed test, it's already been doubled, is 0.129, we'll say. We'll round this to 3 places. Okay, and my fifth step, if you'll recall, is to make a decision. Now, my decision, if p is less than or equal to alpha, I will reject HO. If p is greater than alpha, I will fail to reject HO. So let's see what we have. We have p equals 0.129. We have alpha equal 0.05. And the 0.05 was given. It's right up here in our step 2. So we can see that p is greater than alpha. Therefore, we will fail to reject. Let me write that a little neater. Fail to reject HO. Okay. Now, our summary. Now we failed to reject HO. That means that I have support for the null hypothesis. So for our summary, and there's a lot of different ways that we can say this, but basically the data supports the conclusion that the two types of seed basically yield the same amount. So the data supports the conclusion that the two types of seed yield the same amount on average. So we're still going through all of our tests of hypothesis, all the steps of hypothesis testing. We're still doing all of our steps for confidence intervals. That doesn't make a difference. And then based on that, we're running through the steps 1 through 6. Now sometimes you'll be using a p-value approach, sometimes we'll be doing the traditional critical value approach, and sometimes you get to decide. So just make sure you write out all your steps. Now at the end here, let's go ahead and look at our test statistic real quick. And again, I don't expect you to do this by hand, but if you want to do this by hand, you can. So our test statistic is going to be d bar minus mu sub d, all over S sub d, which is the standard deviation of the differences over the square root of n. Now remember, the differences all have to do with that third column of data that we have in our calculators. Now just be careful while you're working that you double check things like is 0 in the interval, did I reject, fail to reject, and draw a conclusion based on that. Good luck with this assignment, and as usual, if you have questions, please stop by my office, bring your questions to class, or you're also welcome to stop at the Math Center. Good luck.